So this lesson is graphs of logarithms and exponentials. So we're going to review some stuff we did in the first unit, and then we're going to add some new stuff because we're talking about logs and exponentials, and then there's some different key features you talk about when you're doing these. So our learning target is I can find key features of graphs. Okay, all right. So on the left-hand side should be things that you're already familiar with, like exponential functions. You learned about that in Math 1. Whether or not you remember it, it was there. We're going to review it a little bit. And on the right-hand side, you have your logarithm function. So that's something brand new to Math 3. Okay, so an exponential function is the form f of x equals some number to the x exponent. And that number determines whether it's exponential growth or exponential decay. So if the number that's being raised to an exponent is greater than 1, that is exponential growth. So I'm going to draw a little example of what I'm talking about. So I'm going to do something like 2 to the x power. Alright, so remember you read a graph from left to right, and that's definitely growing. So that is exponential growth. If the number happens to be something less than 1, I'm going to do 0.5 to the x power. Then it's going to be exponential decay. I'm going to do this in green, and it looks like this. So it looks like it reflects over the y-axis. But if you read it from left to right, it's definitely going down. Okay, so the new graph is your logarithm graph. So it's always going to look like f of x equals log to some base of x. So here's what that graph looks like. It's a little weird. And if you remember, in the previous lesson, we talked about inverse functions, and we said inverse functions look like they flip over the line y equals x. So look at that blue graph, and look at the purple log graph. They are inverses of each other, and you can tell that because they flip over that line y equals x. Okay, so another thing that may be new, and we're going to talk about this a lot more in our rationals unit, which is a little bit later in the semester. But just want you to understand the definition. This is called an asymptote. An asymptote is a line which the graph gets close to, but it never crosses. So I'm going to do this in red. Okay, so exponentials are always going to have an asymptote at y equals 0, which is just the x-axis. Okay. So notice they get really close to the x-axis, but they don't actually touch it. That's because there's an asymptote there. And there's always going to be an asymptote there at y equals 0 unless there's like a transformation, like you moved it up or down somehow. And we'll look at that in a minute. Logarithms have an asymptote at x equals 0, which is the y-axis. So it gets really close to the y-axis, but it doesn't actually touch it. Okay, so it's a big deal in calculus. You may never use it, I know, in real life, but it is a big deal in the math field. Alright, so a new key feature that we're going to talk about is something called the end behavior. And it's literally just what the ends of the graph are doing. The leftmost end and the rightmost end. Alright, so some weird things that we do when we're talking about end behavior. So it's the behavior as the graph approaches positive infinity, which we'll call the right side, and negative infinity, which is really just the left side. So they're going to use some fancy language, but it really just means the right side of the graph and the left side. I'll show you what I'm talking about in just a minute. So there are 4 types of end behavior. So you could have something, oh, I made a weird butt graph, sorry. But definitely the ends, the left end is going up, the right end is going up. Does not matter what's happening in the middle. It's just what are the ends doing. Okay, and then you might have a graph look something like this. But notice the left end is going down, the right end is going up. So we call that a down and up. I know, very sophisticated name. And then what you could have, something weird like this. But just notice the ends, they're going down and down. And then you could have just something simple. Notice the left end is going up, the right end is going down. So not paying attention to what's happening all over the graph, just the very ends of the graph, what are they doing? Okay, so we're going to do an exponential example first. So we're going to look at the domain, the range, the y-intercept, those are things we've already talked about. So we're going to review that. And then we're going to do new things. We're going to find the asymptote, and we're going to find the end behavior. So what I want you to do right now is either using a graphing calculator if you have one, or using Desmos. I want you to type that in and sketch a little picture. Okay, so I did it in Desmos. I took a little screenshot. If you're using Desmos, I think it's way easier because you can click on little points. Like, if you'll notice, we'll go ahead and do the y-intercept. All I did was just click where it hits the y-intercept, and there I got it. Super fast. Easier than using a graphing calculator. Okay, but if you don't like it, don't use it. We could. Alright, let's talk about the domain. So it definitely goes to the left forever, and it would keep going up and up and up to the right forever. So we're going to say that it goes from negative infinity to positive infinity. So that's a review from our last lesson. Okay, not our last lesson, our last unit, I'm sorry. Okay, so when we're doing the range, remember we say how far down it goes and then how far up it goes. So it definitely does not go further than the x-axis. So it's going to start at 0, and I'm not going to use brackets. I'm actually going to use a parentheses because it can't actually touch 0. It has the asymptote there, and then it goes up forever. Okay, so we talked about this. The asymptote of an exponential is always going to be y equals 0. So think about there being like an imaginary line there that graph gets really close to, but it doesn't actually touch. Alright, so here's the end behavior, and it's weird at first. It's just how they write it, and it kind of throws you off. So we're always going to talk about the left side first. So the way we say the left side of the graph in math is we write as x approaches negative infinity. So we're saying as x goes to the negative infinity, the left side of the x-axis. Literally what this is saying is left side. So if you'll notice, the left side of the graph, the function, it doesn't go down forever. It just keeps going really close to 0. So we're going to say f of x, which is the y-coordinate, gets really close to 0. Goes to 0. So as x approaches negative infinity, f of x approaches 0. You're saying as the left side, as you look on the left side, your graph gets really close to 0. Alright, so then we're going to talk about the right side. Okay, and the way you say right side of math is as x approaches positive infinity, that just means the right side of the graph, f of x, see how it goes up forever? We're going to say goes to positive infinity, goes up forever. So this is saying the right side of the graph goes up forever. Alright. So it's just some symbolic forms. It throws people off. It's really not that big of a deal. Okay, so that was exponential. And now let's look at log. So if you'll go ahead and graph this log in Desmos or whatever you got, and you can go ahead and do the domain, range, x-intercept, asymptote. You can try the end behavior if you really, really want to. Okay, so I did it in Desmos. Here's my screenshot. Notice it already has the x-intercept for me. All I had to do was click. That's so fun. I love it. Domain. It's definitely, it's not going to go left forever. So see how it really stops going at 0? So I'm going to say the domain is from 0 to positive infinity. Because it does go to the right forever, but it doesn't go to the left forever. Range. It's going to go down forever. So it's going to start at negative infinity. And it does go up forever, so to positive infinity. The asymptote's weird. It's got that weird asymptote right here. And that line, if you have forgotten, is x equals 0. And then now let's do the end behavior. Okay, so the first thing we're going to talk about is the left side of the graph. Here's the leftmost side of the graph. Left. See how it's going down forever? Okay, so the way we say left is we say as x approaches negative infinity, and the way we say goes down forever, f of x goes to negative infinity. Alright, and now we're going to say the right side. So the right side, it does keep going up forever. Okay, so the way we say right side is as x approaches positive infinity, f of x, and it goes really slowly, but it does go up, goes to positive infinity. So, literally what you're saying, left side goes down, right side goes up. Okay, I know it's a little confusing. So I want you to try this one. So pause the screen and 1, 2, 3. Okay, so here's your answers. Domain is going left and right forever, so negative infinity to positive infinity. The range, the lowest y value it ever goes to is close to 4, so I said parentheses 4, and then it goes up forever. X-intercept, pretty easy, just click on it. The asymptote has actually moved up because you have that plus 4, so it's y equals 4 this time. And then here's what you're saying with the in behavior. So the left side is going to 4. So see that? It doesn't go anywhere below. You're talking about how far up and down it goes, but this one just starts leveling off at 4. So we say it goes to 4. But the right side goes up forever. So we're saying right side goes up forever. So that's why we wrote it like that. Okay, I'm going to give you one more to try. So here's a log example. You can pause the screen and try it. 1, 2, 3. Okay, so here's what you got. Domain, remember it's how far left and right. It definitely starts at 2 and then goes to the right forever, so infinity. The range definitely goes up and down forever, so negative infinity to infinity. X-intercept's easy. Asymptote is going to be at x equals 2 because you got this minus 2. So if you remember from our last unit when we talked about function transformations, that minus 2 is going to move the graph over 2 units to the right. So here's what we're saying for in behavior. So the left side, if you notice the left side, it goes down forever. So that's why we had it would go into negative infinity. Down forever. And then the right side of the graph, it's going slowly up, but it would go up forever. So that's why it's going to positive infinity, because up forever. Okay, I know that's a lot. So there's an assignment on haiku. You try it. You can redo it as long as it's before Friday at 3:30, and you can send me messages if you need it. All right, bye.